In 6.2, we're going to talk about rates and unit costs. This is a very useful thing in everyday life. A rate is a type of ratio used to compare different types of quantities. When we did this earlier, we had like dollars to dollars or feet to feet. Now, with a rate, we're going to have one label on the top and one label on the bottom. So we'll have 270 milliliters to 13 gallons, or $8.55 for 1 hour. So these are words, these are keywords that imply rates. Per, 117 miles per 2 hours. For, $12 for 3 pounds. In, 400 meters in 43 and 5/10 seconds. On, 270 miles on 12 gallons of gas. So these could be written as rates. You notice that they have different labels. If we want to write rates in the lowest terms, we know how to do that just because we can write them as fractions and we can simplify the fractions. So we'll write each rate in lowest terms or simplest form. In one region, there are approximately 640 trees on 12 acres. So we have 640 trees on 12 acres. So you can see this is a rate because there are different labels, and now we're going to simplify. Let's see. I can divide both of these, I know, by 2. So we'll divide both of these by 2. We get 320 trees on 6 acres. And we can divide again by 2 because they are they're both even numbers. So we're going to divide again by 2. We have 160 trees on 3 acres. And I think that's, you can't divide this by 3. So I think this is in simplest form. Notice that we do keep the labels. LaTanya drove 138 miles on 6 gallons of gas. So this would be our rate, and if we want it in lowest terms, I think we can divide both of these by 6. So we would have 23 miles on a gallon of gas. After a cold front, the temperature changed. Well, it actually dropped 40 degrees in 4 hours. So if we wrote that as a rate, so we have degrees to hours. We can divide both of those by 4. So we would end up with negative 10 degrees Fahrenheit. It's going to drop 10 degrees Fahrenheit every hour, or in an hour. So this is the simplified or lowest terms rate. Now we're going to talk about unit rates, and a rate having a denominator of 1 is called a unit rate. A denominator of 1 is called a unit rate, and you can see that this one is a unit rate. This one is a unit rate. This one is not, because it does not have 1 in the denominator. So the number 1 is often omitted in the denominator. We would say 23 gallons of 23 miles in 1 gallon, or just per gallon. 52 feet per second. $15 per hour. And those are common constructions in our language. So if you want to convert a rate to a unit rate, you simply divide the numerator by the denominator and maintain the units of measurement. So write each rate as a unit rate, round to 3 decimal places if necessary. So you're going to round it to here. If you need to, you may not need to on all of them, but this is with dollars. A health club, excuse me, a health club charges $125 for 20 visits. So what we want to find out is how much per visit or one visit. So we would have to divide 125 by 20. I'm going to use my calculator. 125 divided by 20. $6.25 per visit for one visit. That's the unit rate per visit. $6.25 per visit for every one visit. In 1960, Wilma Rudolph won the women's 200-meter run in 24 seconds. Find her speed in meters per second. So we're going to start with 200 meters in 24 seconds. So what we want is how many meters in 1 second. So we're going to divide 20 by 24. That's what this bar means right here, is divided by. So 200 divided by 24. And I'm getting this number. I'm going to write it up here. And it probably goes on and on. It's a repeating decimal. Our direction says to round this to 3 decimal places. So we're going to round it to here. Our neighbor says drop everything else. So it's going to be 8 and 333 thousandths meters per second. That's the unit rate. We just divided by 24 and rounded it to 3 decimal places. A baseball player for 149 hits in 403 at-bats. Find the player's batting average. The batting average is defined as the number of hits per the number of at-bats. So we have 149 in 403 at-bats. So this is our rate. We want a unit rate, so what we want to know is how much for every one at-bat. So I'm just going to divide 149 divided by 403. And I am getting a screen full of numbers. 9727047, and it probably goes on. We're told to round to 3 decimal places. And our neighbor says is a 7, so it says go up. So it's going to be 370? Now, this would be the batting average. If someone said, what's his batting average? You would say his batting average is 370. So those of you that follow baseball, this would be a nice average. That would be a very nice average. Anything over 300 is a nice average. So this is the batting average. And we would say he has in our language and the way we talk about baseball, we would say this person has a 370 or 370 batting average, where it's really 370 thousandths for every at-bat. So, he's really getting a hit about a little over every third time that he's at the plate. Now we're going to talk about unit cost. How much does each unit of some product or service cost? So a unit cost or unit price is the cost per 1 unit of something. At this grocery store, for example, you might purchase meat for $3.79 per pound. The unit cost is useful in day-to-day life when we compare prices. So, this is some apple juice prices. If it costs $4.19 for a 46-ounce bottle, to find the unit cost or the unit rate, rounded to 3 decimal places again, sometimes you'll need those, when written in dollars. So we're just going to divide $4.19 by 46. And this is what my calculator says. It's hard for me to show you on the video. So this is how much, this is how many dollars, or actually a part of a dollar, that 1 ounce of apple juice costs when you buy this product. So we'll round it to 3 decimal places. And the next door neighbor is a 0, so it's going to be the unit rate or the unit price is 9 1/10 cents. Here's another product you get for $4.89. You get 64 ounces. So to find the unit cost, we're just going to divide. I don't know why that says this. Oh, that's the answer. So you would take $4.89 and divide it by 64. And what I'm getting actually is a little bit more than this. That's what my calculator says. I'm rounding it to the 3rd decimal place or to the hundredths place. And the next door neighbor is a 4. So it's 76 4/10 actually cents per ounce. This is written as dollars. And if we move it over 2 places, it would be 7 6/10 cents per ounce. The last one is $3.55 for 32 ounces. So again, we'll divide $3.55 by 32. And that's what they're showing on here. I'll show you what else comes on my calculator. I'm getting this. That's actually what my calculator says. They've only shown us 4 places because we're going to round to this 3rd one. And the 9 says go up. So it would actually be 11 1/10 cents per ounce. Or this is with the dollar sign because that's what we put in it, written as a dollar. If we put in this, then we're going to get the cents. So we'd have 355 divided by 32. I don't know if you can see that or not, but you actually get 11.09,375. So in the dollar, we have 3 places, which we're going to move this to here if we're writing in cents. So it'd be 11 1/10 cents per ounce. So if we looked at that again, I'm sorry, I shouldn't have pulled that off. Which is the best buy? Which is the cheapest per ounce? We're looking at a little more than 9, more than 7, or more than 11. This would be the best buy. Sometimes we often think of, oh, that would not be the best buy. This would be the best buy because it is the cheapest per ounce. And a lot of times it is the greater quantity. You end up not paying as much per unit, or in this case, per ounce. So this one would be the best buy. This one would be next, and this one would be the most expensive per ounce. And, you know, that can depend on a lot of things. The quality of the product, it can depend on the kind of container it's in. It could be just a pricing ruse to throw you off. Okay, we've got another one here. We're going to do this all ourselves. So we're going to round to the nearest thousandth of a dollar, or 3 decimal places when you're in the dollars. So if we use the dollars, this is going to be 325 divided by 64. And this is what my calculator says, 0.5078125. And I'm going to round it to the third place. The 7 says go up. So this is going to be 5 1/10 cents per ounce, or if we wrote it as with the cent sign, it would be 5 1/10 cents per ounce. The cent sign follows the number, the dollar sign comes before. I see a lot of people that don't quite know what that is. Okay, this one would be $9.59 divided by 160. I'm doing this on my calculator. And this is what my answer is. I'm rounding to this third decimal point place, and the next door neighbor is a 9. So it's going to be that much per ounce. We need that 0 to have a third decimal place, but we're rounding 59 up 1, which would be 60. Or if we want to write this as cents, it's that much, 6 cents per ounce. Okay, now we have $1.95, $1.95 for 32 ounces. So it's going to be $1.95 divided by 32. And this is what I'm coming up with on my calculator, 375. So if I round it to the third decimal place, the 9 says go up. So for dollars, I'm going to write it like this. If I'm writing it as cents, it's going to be this. Okay, so which one is the best buy? We got 5 cents an ounce, 6 cents an ounce, or more than 6 cents. So this is going to be our best buy because it is the least expensive.